Hello friends, so welcome to the class. Today is our second lecture of center of mass. So in today class we will discuss about how to find center of mass of a continuous extended bodies. So for example, I have any extended bodies and I have to find its center of mass. For example, I have a semicircular ring, semicircular disc. So how to start to find, what are the steps we should keep in mind to find the center of mass? So before that, we already studied that to find out the center of mass of a point object. For example, if we have point object of masses m1, m2, m3 and it's kept on the x-axis at distances x1, x2, x3, so the center of mass will be, x center of mass will be m1 x1 plus m2 x2 plus m3 x3 divided by total mass of the system, that is what, m1 plus m2 plus m3. But now I have a continuous extended bodies. So in that case, how to find the center of mass we will see here. So here I will draw one extended body. Let arbitrary shaped extended bodies I will take, and its total mass is m. Total mass of this body is what? M. So what will I do? First I will take a elemental part. Elemental means what? A small part of this whole body, and I will find its position vector. So here just I will take the dm. Total mass is m and a small part of it is what? Dm. So its position vector, let's consider it is what? R vector. Okay. Now I will find its center of mass. Before that, we should understand that whenever we are finding different particles in the system, that time we were using the formula R center of mass was sum of mass moment mi ri, and I was changing from 1 to, I was changing from, sorry, we'll write again, it was mi ri and I was changing from 1 to n divided by sum of the mass of the system mi, where I was 1 to n, correct? So this was the concept behind. If there are so many particles, for example n number of particles are there in a system, that time we are finding the center of mass in this way. But now I have one continuous body, so for this I just took a small part of it, and like this, if I will take dm mass, dm mass, dm mass, dm mass, so it is made up of what? Small dm masses. So that case, whenever we find the center of mass, we can say that in the continuous body system, we can say our center of mass can be written as, because this is sum of the system of particles. Here dm mass is sum I have to take, so I will write integration of what? Dmr, correct? Integration is also not what? Sum only. Okay, so here first I will divide in dm part, and like that so many dms are there, dm, that means small parts are there. Their mass moment sum I will find in terms of integration. Then integration of what? Dm means what? Total mass, that is what? M. Okay, so this will give what? R center of mass. Same way, if I will find x center of mass, that means x coordinate of the center of mass, we can write integration of what? Dmx divided by integration of what? Dm, that means total mass. Just like this only, whenever we are finding the center of mass of different particles in a system, in that case we were finding the sum of the mass moment of all the particles in that system divided by total mass. Here in a continuous body, I took a small part of it, and then I find it at a small part mass moment, like that so many small parts are there, their mass moment integration divided by total mass. That means if I will integrate dm, that will give what? Total mass. So x center of mass I have written. Same way, if I want to write y center of mass, I will write integration of what? Dmy divided by integration of dm, that will what? Total mass. So in this way we can find x center of mass, y center of mass of any continuous body. Okay, so we will deal with some problems so that we can understand in more better way. So next slide is, here you can see here in this question, if you will see, you will find here what given. Figure shows a rod AB of length L, and here it's given that it's having non-uniform density. It means that mass density is not uniform, it is changing, and that is given that lambda equals to cx square kg per meter. Lambda is here given cx square kg per meter, and here rod of length L it is. Here rod of length L it is given, where C is a constant, and find the center of mass of the rod from point A. Point A, we have to find where the center of mass is located. If this rod is uniform, in that case, definitely center of mass will locate at its physical center. But here the rod is not uniform. Here rod is what? Here mass of the rod is variable. It's not uniform. So in this case, the center of mass will be not on its physical center. It will be somewhere else. So how to find the center of mass? So we just studied, whenever any extended body is there, continuous extended body is there, the center of mass, we will use the integration way to find the center of mass. So here we will do the same thing. Here what I will do, x center of mass I have to find. So integration of what? Dmx divided by integration of what? Dm. So first objective is to find dm. So here lambda is given. Lambda is what? Mass density. So here lambda is mass density, that is what? Dm by dx we can say. Mass per unit length. Then dm is what? Lambda dx. Linear mass density. Lambda is what? Linear mass density. That is not uniform. And lambda value is what? Cx square. This is what? Cx square. Correct? So dm value we got, that is what? Cx square dx. Cx square dx. Now I will put this value here and will integrate. And x is changing from what? 0 to L, because the rod length is what? Length L. So it's changing from 0 to L. X is changing from 0 to L. So here I will put the value of dm, that is what? Cx square dx. Cx square dx, and then here dx divided by integration of what? Cx square dx. Correct? We will integrate this on next page. So here we can see that we have to find the x center of mass, and that is nothing but the integration of what? Cx square dx, it was x here, divided by, integration of cx square dx, that was dm, into x, divided by integration of cx square dx, this is the dm, and the integration limit 0 to L, 0 to L here. This is nothing but the x center of mass. Correct? Now here x will multiply with the x square, it will be what? Cx cube. C will be outside because it's constant, then it will be x cube dx, 0 to L we will integrate, divided by C outside, x square dx, 0 to L. Now here cc will cancel out. Finally we can write it as a x power 4 by 4, and because L is 0 to L limit is there, so we can write it as a x power 4 by 4 L 0, and here x cube by 3, upper limit is L, lower limit is 0, so it can be written as 3 will go up, 3 by 4 into L power 4 divided by L power 3. So here it will remain 3 by 4L, and this is the position of center of mass. This was the rod, and here the position A was here. So if length of the rod is L, center of mass will lie at what distance? 3 by 4L. Okay, so somewhere here center of mass will lie, that is what distance from here? 3 by 4L. Correct? So we'll go for the next question. Okay, so we have to find the center of mass of a uniform half ring. Okay, so we will take one uniform half ring here. We will take a uniform half ring. Okay, and here let mass of this ring, total mass of the ring is m. Okay, and then we have to find its a center of mass position from this origin point. Okay, let the radius of the ring is r, total mass is m. Now you see here, when I will take along the x-axis, see here, I will keep my hand in the middle. So see here, it is uniform from both sides. If you see here, right side and left side, both are what? Same, symmetrical both sides. When I will keep my hand here along y-axis in this way, so it means what? X center of mass is on the physical center. Why? Because here when I am keeping my hand in the middle, so along x-axis when I am going right and left, so I am here what? The both sides are symmetrical. Ring here same, here same. So the x center of mass will be what? At physical center. So x center of mass physical center, that means it will be on origin only. Our objective is to find what? Y center of the mass. Why? Because here when I am keeping on y-axis like this, okay, so upper and lower half is not symmetrical. Okay, so in this case definitely center of mass will be not at physical center, it will be somewhere up than the physical center. So we have to find what? Y center of mass. So x center of mass will be on physical center. Our objective is to find what? Y center of mass. So we will use the same formula, dmy, integration of dmy divided by integration of what? dm. Now what is a dm? See here, integration of dm, we can write it as a integration of dm means what? Mass. Dm is what? Smaller mass. Dm is what? Smaller mass. That means elemental part of it. So from here I will take an elemental part of it. Let from here I will take an angle theta, and the d theta angle I will take. So if radius is r, so this length is what? R d theta. This length is what? R d theta. Now the mass on this part is nothing but a dm. This part is what? Dm. So like that dm part, if I will add, the total mass is what? Capital M. Okay. So how will I write dm? Because dm, it is a ring. So ring means what? The mass will be distributed along the length. So mass will be not on area, it will be on the length only. And here one thing you see, that theta is changing from what? At this point to this point. That means if I will take the theta limit, so it is a two-dimensional case. Theta is coming from minus pi by 2 0 and then 0 to pi by 2. So from here if I will write minus pi by 2 to plus pi by 2, theta is changing. Or if theta, because reference line is this one, so I can write minus pi by 2 to plus pi by 2. And dm I can write it as a dm equals to m divided by pi into d theta. Now why I have written like this? Just try to understand. Here the length is rd theta, correct? Length is what? Rd theta. And this total angle, this one is what? Pi. This one is what? Pi. Correct? Now I am finding here, if this is the pi, so this length is what? Pi r. This length is what? Pi r. So can I write it as a m divided by pi r, mass per unit length? And here I am finding the mass on rd theta length. So can I write it as a rd theta? So if I will cancel this r, it will remain what? M by pi d theta. Because here mass is distributed over its length. Keep it in mind whenever you are finding a dm. First thing you should understand, mass is distributed over its length, area or volume. So here because it is on the length, so I just written m by pi r, because pi r is the length of this half ring. 2 pi r is for full ring, for half ring it is what? Pi r. And the length on which dm mass I am taking, that is what? Rd theta only. So dm we got, that is what? M by pi d theta. So here I will write integration of what? M by pi d theta when I am writing what? Dm integration. Now here theta, how will I take? So theta, when you will see, theta is the reference line, this one, it is going from, if you reference line means at this point is a 0 and it is going to the pi by 2. Same way here we can say that it's coming from minus pi by 2 to 0 and then 0 to pi by 2. So here the limit of theta will be minus pi by 2 to plus pi by 2. Correct? Now we will use this formula and we'll solve this. So here I can write it as an integration of dm, and dm, as I told you, It is what? M by pi d theta. M by pi d theta. And the y, what is the y here? Here y is the y coordinate of dm. So dm is here. So what is the y coordinate of this? This is the r radius from here. So this is what? R cos theta. When you will take the coordinate of this along y axis, this is what? R is here. This is what? R cos theta. So what can I write about the y coordinate? R cos theta divided by same integration of dm. That is what? M by pi d theta. Correct? Now our objective is to integrate it, and limit will be minus pi by 2 to minus pi by 2 to plus pi by 2. Here minus pi by 2 to plus pi by 2. Correct? So we will integrate this. So here we have to find y center of mass, and we have written already, this was m by pi. So m by pi constant outside we can take, okay, and it was r cos theta. So r also I can take outside, and cos theta d theta will be inside. It will be from minus pi by 2 to plus pi by 2. Same way down it was m by pi. Correct? M by pi integration of d theta minus pi by 2 to plus pi by 2. Now m by pi cancel out, so it will remain r only. Now integration of cos theta d theta will be what? What is the integration of cos theta d theta? So integration of cos theta d theta you can write sine theta plus c. Correct? Okay. So here you will write, this is what? Sine theta, and limit is what? Pi by 2 minus pi by 2. Upper limit is pi by 2, lower limit is minus pi by 2. Now d theta integration theta pi by 2 minus pi by 2. Correct? Here we will put the value here. So finally we will get here r sine 90 degree value is 1 minus, and then minus sine minus theta minus sine theta, it will be 1 plus 1. We divided by here pi by 2, and then minus minus plus pi by 2. Correct? So here it will be 2r by pi by 2. Pi by 2 is what? Addition, it is what? Pi. So we will get the y center of mass is 2r by pi. So if I will take a ring, half ring here, if I will consider a half ring, so its center of mass from the origin will be at what distance? 2r by pi. 2r by pi. Okay. So x coordinate will be at 0 only, but y coordinate is what? 2r by pi. 2r by pi. Correct? So in this way we can find a different type of continuous bodies, center of mass. We will continue the same type of questions, same type of bodies in next class. Thank you.